example 7 is very similar to example 6, but there is no picture given. You are supposed to come up with the equation of the function just based on a verbal description. So in example 7, we need to find the 5th degree polynomial function that has a y-intercept at 0.72, crosses the x-axis at 2, and touches the x-axis at both -2 and +3. All right, we are going to approach this problem just like we did with example 6. To come up with the equation of this polynomial function, we're going to build the factorization, okay? So that is very reliant upon the zeros, okay? We are told that there are 3 zeros, one at 2, one at -2, and one at 3. Okay, so I'm going to go ahead and list these guys out. So first of all, we have an x-intercept or 0 at x equals 2. So basically what we need to do is come up with the factor. Okay, so essentially this is, working backwards to come up with the factor that will produce x equals 2 as an x-intercept. Okay, so I am going to subtract 2 from both sides because I'm trying to make one side equal 0. And so I'm going to get x minus 2 is equal to 0. Okay, so that means x minus 2 is going to be your factor. Okay, because if you take this factor and set it equal to 0 and solve, you're going to get the x-intercept or the 0 of +2. Okay, so the first thing that needs to go in our factorization is x minus 2. Okay, so I'm going to come over here and start building the function. Okay, so far we've got x minus 2. Okay, now remember, you have to pay attention to multiplicity. Okay, so we are told an important piece of information here. We're told that our polynomial function crosses the x-axis at x equals 2 at this particular x-intercept or 0. Okay, so since we cross here, okay, that's going to be an odd multiplicity. And we're going to keep our function as simple as possible. So we'll just stick with a multiplicity of 1. And so that means x minus 2 will appear in the factorization just one time. Okay, there won't be a square on it or anything like that. Okay, all right, so let's move on to the next 0. Okay, so the next 0 is going to be at x equals -2. Okay, so then again, we're trying to come up with the factor. So I'm going to move this over so that one side is 0. And that tells me that x plus 2 is equal to 0. Okay, so once we get one side equal to 0, here is your factor. Okay, so the reason is, okay, that this is the factor is because if you take x plus 2 and set it to 0 and solve, you're going to get -2. Okay, so that's why, if x equals -2 is a 0 or an x-intercept, that means x plus 2 is the factor it came from. Okay, so I need to go over to the factorization and I need to add x plus 2. Okay, all right, now we need to go back and look at the information about crossing and touching. For x equals -2, we're told that the graph is going to touch the x-axis here. Okay, so that means so let me go down here. That means that, this at x equals -2, the polynomial function touches. Okay, so that means we need to have an even multiplicity. Okay, we want to keep things as simple as possible. So the lowest number of the lowest even number we can use for our multiplicity is 2. Okay, so that means this factor is going to have multiplicity of 2, so it's going to appear in the factorization 2 times. Okay, so you can come back up here. It's up to you. You can put a square on it, or you can just put another x plus 2. Okay, but it's got to appear twice. Okay, all right, so here we go. For the third x-intercept, okay, that is located at x equals 3. Okay, again, I'm working backwards. I'm going to move everything to one side to get the factor. So if I subtract 3 from both sides, let's see, if I do that, I'm going to get that x minus 3 is equal to 0. So x minus 3 is going to be our remaining factor, okay? And the reason for that is because if you take this factor of x minus 3, you set it to 0 and you solve for x by adding 3 to both sides, you're going to get positive 3 as your x-intercept, or 0, okay? All right, so we know that at x equals 3, our polynomial function is also touching the x-axis. So since we're touching here, x equals 3 also needs to have an even multiplicity. Okay, so we'll assign it the simplest thing possible, a multiplicity of 2. Okay, so we need to go over here to our function and we need to have, hang on a second, let me rewrite this so it's kind of squished. I'm running out of room. All right, so I shifted it over. So now we need to add in the x minus 3 factor. And since it has a multiplicity of 2, it needs to appear in the factorization twice. Okay, so we can simplify this. Okay, we can write x minus 2, and then we have x plus 2 times x plus 2. We can write that as x plus 2 squared. And then we have x minus 3 times x minus 3. We can write that as x minus 3 squared. Okay. All right, so we're almost there, okay? There is one piece of information we have not handled yet, and that's the fact that this polynomial function that we're looking at is going to have a y-intercept at 0.72, okay? Now, every time I teach this in person and I give this example and I ask people what to do, even after we've done example 6, the number one answer I get is to just go, hey, plus 72 at the end, okay? That is not right, okay? Remember what we did in example 6. We had a point that we knew was on the graph of the polynomial function. You have to plug the point in, okay? So same thing here. If your x value is going to be 0, then the y value has to be 72, okay? So we're going to have to plug in for it and remember what we're solving for, okay? Because our polynomial is being forced through this specific point, we have to put a leading coefficient out front that we call a, and we're going to plug in the point. We're going to plug in x equals 0 and y is 72. That's going to allow us to solve for the specific a value, the specific leading coefficient that we're going to need to force this polynomial through the point 0.72. Okay, so here we go. Let's do this. All right, I am going to rewrite this. So let's see here. I'm going to kind of set it up. So we're going to be plugging in for x. Okay, so let me go ahead and write this down so we can just plug in the next step. All right, so here we go. If x is 0, okay, we're going to get a times 0 minus 2 times 0 plus 2 squared times 0 minus 3 squared. Okay, so we've plugged in x equals 0 on the right side. So if x is 0, f of x or y has to equal 72. Okay, this is going to leave us with just a as a variable, and we're going to be able to solve for it. Okay, so this is going to tell us that 72 is equal to a times 0 minus 2 is negative 2, and then 0 plus 2 is positive 2, but that's going to be squared, and then 0 minus 3 is going to be negative 3, but that negative 3 is going to be squared. Okay, so this is going to be 72 is equal to a times negative 2 times 2 times 2 times negative 3 times negative 3. All right, so we're going to get, if we simplify what's on the right, we're going to get 72 is equal to a times negative 2 times positive 2 is negative 4 times 2 is negative 8 times negative 3 is positive 24 times negative 3 is negative 72. All right, so if we want a, all we need to do, since it's being multiplied by negative 72, we need to divide both sides by negative 72. Oops. And so this is going to tell us that, let's see, let me finish writing this. Okay, so we're going to get on the right side, negative 72 divided by negative 72 will cancel. So a is going to be 72 divided by negative 72 is negative 1. Okay, so there's your leading coefficient that you need. Okay, and so now your very last step has to be to write the final answer. So write the equation of the polynomial that you're looking for, okay? So remember, this is what it looks like, okay, right here, okay, right here at this point. Okay, I had the factorization, but I need to go back and stick in the leading coefficient out front. Okay, so let me see if I can kind of keep, well, trying to keep it in the same line of sight here. No such luck. I think I'm out of room for writing. All right, so basically our answer, and I'll write it at the end, our answer is going to be f of x is equal to -1. Okay, that's going to be the a value. Okay, so actually, let's look right here. This is the best place to look, right here. Okay, so the final answer is going to be a, which is -1 times x minus 2 times x plus 2 quantity squared times x minus 3 quantity squared. Okay, that's going to be the final answer. You have to go back and say what the a value actually is. Okay, so the final answer, like I said, is going to be -1, which I'm just going to leave it as a negative sign, times, let's see, x minus 2 times x plus 2 squared times x minus 3 squared. Okay, this is the final answer. Okay, the great thing is you can check yourself by plugging this thing into a calculator to make sure the picture you see matches the verbal description that you were initially given. Okay, so I'm just going back up to make sure that I wrote this equation down correctly. Okay, all right, so let's give it a shot. Let's see here. I'm going to go to my calculator and I'm going to punch in into y equals what I just said was the final answer. So we're going to have a negative sign and then x plus 2, or sorry, x minus, oops, let me check, x minus 2. So x minus 2, and then we've got to multiply that by x plus 2 squared, and then we've got to multiply that by x minus 3 squared. Okay, and I'm going to adjust my window. Okay, so remember I had x-intercepts at -2, +2, and then 3, I believe. Okay, so yes, it is fine to keep our x-axis as is. -10 to 10, we should see all of those x-intercepts, and I'm going to put a tick mark every 1 unit. On the other hand, though, with the y-axis, remember our y-intercept is at 0.72. And so I'm going to adjust I'll keep my smallest y value at -10, and then I'll make the biggest y value 100 so that I see 72 as the y-intercept. Okay, might have to adjust all of this after we get a first glimpse, but that's where I'm going to start. And since we're going as high as 100, I'm going to adjust my y scale to be 10. I'm going to put a tick mark every 10 units. Okay, so let's see what this looks like. Okay, so that's pretty good. I may want to see a little more of the negative y-axis, so I'm going to go ahead and adjust that. Let's make the smallest y value -100 as well. Okay, so now we get a better looking picture. Okay. All right, so let's first check out the y-intercept. If I do a second trace or a second calculate, option 1, figure out what's going on at x equals 0. You can see at the bottom that the cursor is on the point 0.72, so that is indeed the y-intercept. So now let's check out the x-intercepts. I do see one at -2, okay, and at -2 we are touching. Okay, so let's go back up to our verbal description. All right, so at -2, we should be touching both at -2 and +3. So let's look at that. All right, so touching at -2 and +3. Let's see here. Here we go. Okay, so here's -2. You see where the arrow is. Okay, so I'm touching there. And then at 1, 2, 3, we're touching there at that x-intercept. Okay, the other x-intercept was +2, and according to our verbal description, at +2, we should be crossing there, and we are. Okay, so it looks like we have indeed come up with the correct equation for our polynomial.